Hi. 1 second. These black bars seem to be in the way. Hello. Oh my gosh, I've been cubified. Oh well. Welcome to our video. We will be investigating if more time for memorization increases the amount of items you can recall. We think finding the optimal time for memorization is essential, as spending too little time can prevent you from memorizing anything, while too much time can take time out of other important things in your day. It is that balance of the benefit of more memorization and the benefit of the next best alternative that ensures we get the maximum benefit from our time. So, before I explain our experiment, let's get data collection going. Okay, let's go meet some of our subjects. Hello.
Hello?
Oh, hey. Would you be willing to participate in my experiment?
Sure.
Okay, let me flip a coin. Looks like you got 30 seconds. Here is our list of 20 words. Okay, I'm timing you. As we wait, let me explain my sampling procedure. We sampled CV students from the quad in the library to infer whether 60 seconds lets them memorize more items on a 20-word list compared to just 30 seconds. So here's our list of 20 words. We collect 60 students total. 30 students will have 30 seconds of memorization time, while the other 30 students will have 60 seconds of memorization time. We determine who gets 60 seconds with a flip of a coin. This is the element of random assignment. We will tell the subjects that they will have X amount of seconds to memorize a list of 20 words. Once the time ends, the experimenter will take away the list and ask the subject how many words they remember, in any order. Spoken words that are not on the list will not lose points. The experimenter will count up all the words that they do remember. Here's a flowchart of our procedure. Some possible problems with our sampling is we only pick subjects from the quad and library, which may hurt generalizability to the full population of CV students. Our small sample size can also introduce variability, which makes our conclusion less decisive. Next time, we should pick people from more places and get a larger sample size in general. Wait a minute. It's been greater than 30 seconds. Put the list down.
No!
Ouch. This was supposed to be a simple stats project. She's probably fine. Well, I don't think she's getting up anytime soon, but let's include her results in our data of the 60 people we sampled. Here's the two charts of our data and another one. Here's my graphs. And here's my mean and standard deviation calculations. The mean for 30 seconds is 6.267 words, while the mean for 60 is 9.567 words. Standard deviation for 30 seconds is just 3.47 words, but for 60 seconds it is 1.5 552 words. And here are my calculations for potential outliers. With respect to the box plots, the 30 seconds has a lower median than 60 seconds at 6 words versus 8.5 words. The range of 60 seconds is much wider than 30 seconds at 15 words versus 7 words. 60 seconds has two outliers at the extreme end of words remembered at 17 and 19 words. Both are about unimodal and normal. And let us conduct the inference test for the two mean t-tests. We did random assignment. Central limit theorem is met as both of our samples are of size 30, and we meet independence with 10% conditions as there is more than 300 students at CV. Here's a picture of our conditions. Now here are my calculations. We got a t-statistic of 4.75 and a degrees of freedom of about 40.15. Finding the probability of getting a t-statistic greater than 4.75, we get a p-value of approximately 0. And here's a more digestible graph of that. As you can see, the p-value is less than the alpha of 0.05. So we reject the null hypothesis. We have convincing evidence that the true mean words remembered is greater for 60 seconds of memorization than 36 seconds of memorization for the population of all CV students. So, is it really different? In a statistically significant way, yes, we can say it. It is. Practically, we think so. While doubling the time of memorization did not result in participants remembering double the words, in terms of a 20-word list, participants remembered 16.5% more on the list with 60 seconds compared to 30 seconds. In terms of academic performance, such as a test, this is more than a letter grade difference when considering the higher grades of A, B, C, and D. In terms of job performance, being able to remember like 16.5% more procedures will ensure both efficiency and smooth operations at a work site. Yet, as the mean of words remembered for 30 seconds is 6.2667 words and versus for 60 seconds 9.667 words, doubling the time does not result in doubling the amount of words remembered, but rather only a 50% increase in words remembered. This seems to indicate diminishing returns with greater memorization time. We expect that the true relationship between time of memorization and items remembered would be modeled by a negative exponential function with a high rate of change from 0 to 30 seconds to the rate of remembered items to time decreasing rapidly with more time. This brings us back to our discussion of the optimal time to spend on memorization, where too much time on memorization can bring less benefits than using that time to pursue the next best alternative. While in most contexts, spending 60 seconds will likely be more beneficial than pursuing other activities, especially for academic performance, the potential benefit for more time for memorization would highly depend on the next best alternative and the situation at hand as to why one needs or wants to memorize a set of items in the first place. One thing is clear. More data is needed with longer times for memorization to visualize a complete relationship. Which brings us to one of the major limitations of our project, the lack of resources to collect more data over a wider variety of times. Without more times of memorization, like 2 minutes, 3 minutes, or even an hour, we struggle to model a complete relationship between memorization time and the amount of words or items remembered. Another limitation is that we only selected from the quad and library, which hurts our ability to generalize our results to a wider population of all CVHS students. We were also very limited in our subject size, which introduced more variability in our subjects. Ways to improve our study would be to get more researchers to get more data, to get a list of all students, and then use a random number generated to assign our subjects, and simply select more subjects to study. You know.